So basically there could be an instance where I give you some information and I tell you that in this case determine the height of the triangle given that the base is QR. So you know QR goes here, right? And triangle QRS, QR is here, and you fill in everything, you find the height, okay? And this is how you do it. This is on page 40. Then I ask you give a value to satisfy the following conditions, right? What would the length of RS, like what would the length of the string have to be, this string, to have no possible triangle? And the answer is, once you find the height, right? If the string is any bit shorter than the height, you don't have a triangle. So you answer it not with a specific number, you answer it like this. You can also say string if you want. The string would have to be less than the height, right? So you write it down like this, whatever the height is, that goes there. If the length of RS, right, you want one oblique triangle, just make sure that your string is greater than the rod, right? So you take your string, which is RS or SR, same thing. You just want it to be larger than the 36. If it's exactly equal to, then that also works. That's an isosceles triangle. String is greater than or equal to rod. The length RS so that you have two possible triangles. So this one is tricky. I remember now posting a video on this. So if RS is smaller than the rod, so if your string is smaller than the rod, but bigger than the height, like RS is being used twice here, that's when you have two triangles. So you can state it like that if you want, or you put it in between like this, where the string is in between the height and the rod, right? That would give you anything in between there would give you two triangles in this particular case. And then what is the string? Remember, RS in all of these cases is the string. What would that have to be to get one right triangle? And the only answer there is the string would have to be exactly equal to the height. Right? And so something like this I would expect you to know how to do. Okay. Just go back and look at, I don't know when this would have been, last week Wednesday maybe. I think it's called homework correction or something like that. So that's where I go over it slowly and I fill in this part. Right? And there's another one you can try here. Okay, so I will move on because I actually want to do talk a little bit about word problems and stuff like that. So basically go through your notes, flip through your notes, review that way, make sure your study sheet has a way to determine how many triangles are possible, all that stuff. But I will tell you this, it's not going to be the heaviest on what we just did. There's going to be one most likely that will be ambiguous and you have to solve. But most of them are going to be word problems that we've done up until this point, like up until the quiz, right? That's going to be the meat and potatoes of the test. Like, let's not kid ourselves, right? That's going to be the heaviest, right? So let's go back a little bit. I have a triangle here or a question here that I had already earmarked on page 26. I put down test prep. And this has just a little added level of maybe difficulty, but it's really not that bad. But remember, distance is going to be speed times time. Okay, if you travel 100 kilometers an hour and you travel for 2 hours, you will have traveled 200 kilometers, correct? So that's the same. This is always true. Okay. So it says Dawson walks. This is a speed here, right here. That's speed. 4 kilometers an hour. It doesn't say it just walks 4 kilometers. It says 4 kilometers an hour in the direction north 40 east. So that's important. There's the speed. There's the direction. And then Rod leaves from the same location at 6 kilometers an hour in this direction. Page 26, yeah. How far apart are they? What's that? After 2.5 hours. So we will say that 4 kilometers an hour, right, times 2.5 hours, we'll figure out that distance. 2 kilometers an hour for a rod times 2.5 hours, we'll figure out that distance. So I just wanted to know how to do it should it ever show up, right? 4 times 2.5 is 10 kilometers. And then 6 times 2.5 on page 26. That's 15 kilometers. So this is for Dawson, and this is Rod, right? So we actually now have a distance. So we took care of the speed and the time. So after 2.5 hours, this is the respective distances that were traveled. So let's get it out of the way, and let's get back to our question now. Dawson walks in a direction north 40 east. So I'm going to go right about here. North. Remember I told you if you can have a ruler. I'm going to start doing this. North. Okay. Make it very clear that's my north line. 40 east. Remember your north, east, west, south, okay? So I'm going to turn 40 degrees this way. So the 40 is there. This is my story. 10 kilometers. So that there's a limit to the distance traveled there. Boom, right? So I'm going to call this Dawson because, or D, because he ends up there, right? And then the next one says what? Rod leaves from the same location, but this time it says what? Leaves east, 80 degrees south. East, 80 degrees south. So I'm going to go ahead and do that. This is the east line. And I'm turning 80 degrees, which is quite sharp this way. And this one is 15 kilometers, correct? I'm not, because the question doesn't tell me that I line up perfectly. I'm not going to line up. Maybe what I will do is I'll make I make it like this, and just make sure you don't line up north-south, because they don't give any indication that that's the case, and this is 80 degrees. So this is your east line. This is your north line. Okay. Now so this is how I read it, and now this is Rod, that's Dawson. Now we want to know how far apart they are. I'm gonna leave that out. I'm gonna just include that on my final triangle here. Dawson, Rod, I'm gonna call this S for start. And this is X, that's the side that I really want, right? And you should see, you're going to try to do the alternate interior, right? Because I showed you that so many times. Sure, you can do that. You can say, hey, there's also a north-south line here. I can bring the 40, but that wouldn't be part of this triangle, would it? It would not be. But the northeast line is right here. Sorry, north and east, they make a 90, right? There's a 90 there. So I can figure this out by going what? 90 minus 40. So you have to be creative. So that's 50 degrees actually. And I will highlight that that's new. Okay. So to get S, what do I have to do there? I add the 50 and the 80 together in this case, right? Because 80 represents this, 50 represents that. So 80 plus 50, that's 130 degrees, and that's what I'm going to write in here. I have 10 kilometers, I have 15 kilometers, and this is SAS. Coleslaw. Coleslaw. You. Let me just get the. I might just give you the key here, and then we'll move on, because I'm just interested in more of the actual drawing, setting it up more than anything else. Lo and behold, I don't have the key. So we have to do it. There's no other way. There's no other way. Close at 130. So that's 100 plus 225. 22.76 kilometers. And it makes sense, it's an obtuse angle. It should be the furthest, longest line in the triangle by far. So that's just it. Okay, so you have that. Before you go, just pick this up. Let's go to the previous page, 25. This is going to be our last goal. I think I'm just going to ask you to read this. Yeah. I'm just going to ask you to read this and sketch it, because I'm not going to solve the whole thing. I'm just going to see if you can sketch it, but I will give you the answers to this one. I do have the answers to this one. So read it and see if you can come up with a diagram. Read it, and then I'll come around and give you the handouts, okay? Before we go, what does it mean going straight due west? You should know by now. You're going exactly west. You're going sideways. So you leave Winnipeg towards Brandon, this distance. Once in Brandon, heads this direction to drop off passengers at Russell. The town is this far apart. What does it mean as the crow flies? It means that it's the direct distance. Like a crow can fly over everything, right? It doesn't have to drive the streets. So it's like a direct distance. I wanted that in there because sometimes it does show up. Sketch a scenario. So I'm going west, right? So this is Winnipeg. I'm going straight west to Brandon. And that's 132.8 miles. Once in Brandon, You go west, 63 north. And I messed this up. I need to go lower. Why would you do that? Because that's going to happen, right? So you just go a little lower. I'm going to redo the whole thing. So Winnipeg, Brandon, 132.8 miles. So this is my west line. So I kind of extend from here. I extend from here, west, and then I turn 63 north, like this, right, to go to Russell. Notice that the town of Russell is from Winnipeg. As the crow flies, this is actually a side. This is actually like this. Where's the 60, guys? 63, sorry. 63 is out here, correct? Can you find inside the triangle? Yes, because it's a straight west line. That's why, the only reason why. I will post the key to this one on Google Classroom and all the handouts I gave you, okay? Be early tomorrow. Wake up early.